So this is a pop quiz 1, which was related to unit 2. The energy changes. So first, which are the correct for the reaction as shown? As you can see, enthalpy change is negative. If there's an enthalpy change negative, it means it must be an exothermic reaction. Or either C can be an answer or D. Then this is an acid and this one is a base. So acid is reacting with the base. So when acid is reacting with the base, what we call these reactions, we call that as neutralization. So this is a neutralization reaction and exothermic. So D will be the right answer. The next one, which equation does not represent the standard enthalpy change of atomization? Standard enthalpy change of atomization means when we produce 1 mole of atom from a gaseous, 1 mole of atom is produced in a gaseous state, we call that as atomization. So here, magnesium, we are producing a magnesium. 1 mole of a magnesium atom in a gaseous state, 1 mole of oxygen in a gaseous state, 1 mole of mercury in a gaseous state. But here it's producing 2 moles of chlorine in a gaseous state. So this is not atomization standard. This is a twice the standard enthalpy change of atomization because 2 moles of gaseous atoms are produced. Atomization means when we produce 1 mole, standard enthalpy change of atomization means when we produce 1 mole of a gaseous atom. We have 5.2 grams of a sodium hydrogen carbonate was added to an excess of an acid. The temperature increase and the enthalpy change is calculated, which is 1030. What is the enthalpy change per mole? So we need enthalpy change for 1 mole, like delta H divided by number of the moles. Energy change is calculated. So enthalpy change or energy change per mole we need. So it will be E divided by mole. And the answers are given in kilojoules. So we have to convert this into kilojoule. We divide by 1000. So it will be 1.030 kJ. And moles, how to work out the moles? Mass in gram over molar mass. So mass in gram is 5.2. Molar mass of a sodium hydrogen carbonate is given 84. This will give us the moles. So energy divided by, and we have the options. So when we simplify, we'll get B as a right answer, like 16.6 kilojoule. Why negative enthalpy changes are there? It means like the the reaction is exothermic. So the total energy divided by moles, we'll get enthalpy change per mole. Here the equation is there for a complete combustion of methanol. What is the bond enthalpy for methanol? So we will have a bond breaking energy. We'll have a bond forming energy, and bond breaking minus bond forming will be equals to enthalpy change of this reaction, which is minus 591. Bond breaking energy, the C double bonded with O. This is what we need. So this is X. So this one is X, and CH bond 413. So this will be twice of 2 into 413 plus oxygen double bond is 498. So this will be 498. This is the bond breaking energy. Bond forming energy, OC bond is 805 and 2 of them. So 2 multiplied by 805 plus OH bonds are there. 1 is 464, so 2 are there. So 2 multiplied by 464. So we just substitute this in equation like X plus 2 into 413 plus 498 minus the bond forming. So this whole product will be subtracted 805 plus 2 into 464, and that is equals to minus 591. Then we have to simplify this. to get the bond enthalpy, like when we get the value of X here, so it will be 623 kilojoule per mole. Like you have to simplify this mathematical equation to get the value for X, which is a bond enthalpy for C double bonded with O. Question 5, which is related to enthalpy change of a combustion, can be determined by using a calorimeter or can be calculated by using the Hess law. We have to complete the table. Mass of a spirit in the beginning and at the end. So mass has reduced, how much the mass has changed. So you just have to take a difference. It will be subtracting, so it will 0.57. And the temperature change 65.3 minus 19.5. So that is equals to 45.8. Remember, temperature change in degree centigrade and Kelvin will always be same. So if it is in degree centigrade, the change in Kelvin will also be same. We need the enthalpy change of a combustion. So first we work out the energy. How to work out the energy? E is equals to Cm delta T. And after getting the energy, enthalpy change per mole, energy divided by moles. How we know the moles? A sample was burned. So first the specific heat capacity of a water 4.18. The mass of the water which was used 75. And the temperature change is 45.8. This will give us the energy in joules. Don't forget to convert into kilojoules. So 14358 joules. Then we'll convert into kilojoules. We divide by 1000. So it will be 14.358 kilojoules. And to get the moles equal mass in gram over molar mass. So how much? This is 0.57 mass in gram was there. And the molar mass of 2-methyl propane 2-ol, like 2-methyl, second position you have a methyl and second position you have alcohol. It's a tertiary alcohol. When you work out the total mass, like 4 carbon atoms are there. So 12 into 4 plus oxygen is there, 1 oxygen is there, and then hydrogen are 10. So 1 into 10. So it will be 12 into 4, 48, 58, and then 74 will be there. So this will be 74. So divide, you'll get the moles, which is 0.007. The enthalpy change was 14.358 divided by 0.007. You'll get the enthalpy change per mole, which is 1 point. Like 1864 kilojoule per mole. And the negative sign should be there. The 1 mark is for the negative sign. How you identify that there must be a negative sign? Because the temperature has increased. If a temperature increase, it means the reaction is exothermic. Then the standard enthalpy change of a combustion can also be used to calculate the enthalpy change of a the standard enthalpy change of a combustion can be calculated using and formations as well. Why formation for oxygen is given 0 or not given a, because oxygen does not form here. Like if substance is formed, then oxygen is an element and it's in a standard state. So for element, the formation is always 0. So element, because formation means when compounds are formed from element. So a simple answer, oxygen is an element. That's why its formation has not given. Then we have to complete the cycle for the Hess law. here first the balance equation should be there. So if you try to balance equation, start with carbon followed by hydrogen and at the last oxygen. So four carbon are there, we want to balance, so we put four carbon is balanced. Hydrogen are 10, so we will put 5 hydrogen is balanced. Add oxygen, 4 multiplied by 2, 8 plus 5, 13, so we need 13. 1 is already there, so we need 12, so 6 multiplied by 2. And what are the elements used here? So element will be oxygen and element will be hydrogen. And total, how many oxygen are there? So it's like 13 are there, so 6 by 2 and 10 hydrogen, so 5 by 2. Here, this is a formation of alcohol, and here this is a formation of a carbon dioxide and water. So calculate, so how we can use this? The overall energy change is independent of the route or the path we follow. In a Hess law, where the two arrows are pointing out, that is the start of the cycle. Where two arrows are pointing in, that is the end of cycle. So if we follow route 1 or we follow route 2, the energy change will be equal. So this is a formation of alcohol, which is given minus 359. So this is minus 359. This is a combustion, we don't know, so we say X. And this one is a formation of carbon dioxide, but 4 molecules are formed. So it is 4 into minus 394 plus 5 into minus 286, because 5 water molecules are formed and 4 carbon dioxide molecules are formed. So when we follow, like, write this, so it will be minus 359 plus X is equals to 4 into 394 plus 5 into minus 286. We've solved for X, minus 359 will move other side and we'll get the enthalpy change of combustion, which will be obviously a higher value compared to the practical one, because the practical ones there are losses as well. So when we simplify, we get minus 2600. Then why the enthalpy change of a combustion obtained in part 2 is much less than B3? Like, why practical value? Because this was practical and this is by using the standard values. Two reasons we have today. So, reason for other than non-standard condition. Like, so what might happen, because practically there is always a heat loss. So some heat loss to the surrounding during the experiment, and there might be incomplete combustion. Some of the alcohol might lost due to evaporation. So heat lost or alcohol evaporated, or incomplete combustion may happen. They all will leads to a lower enthalpy change value. So these are the practical reasons why the enthalpy change by using the calorie